In today's lecture, we'll be seeing about multiple access scheme. There are two types of multiple access scheme. One is carrier sense multiple access with collision avoidance. The other one is carrier sense multiple access with collision detection. The main difference between carrier sense multiple access, collision detection, and carrier sense multiple access with collision avoidance is that carrier sense multiple access collision detection is mainly designed for a wired network, whereas carrier sense multiple access collision avoidance is mainly designed for a wireless network. We'll see why CSMA bar CD fails in a wireless network. CSMA bar CD is carrier sense multiple access slash collision detection fails in a wireless scenario. There are two reasons. One is the hidden and exposed terminal problem. The other one is the near and far terminal problem. First, we'll discuss about what is meant by hidden and exposed terminal problem. So now we'll see what is meant by hidden and exposed terminal problem. Let us consider there are three mobile nodes A, B and C. Let us assume that the transmission range of A reaches B and not C. Let us assume that the transmission range of B reaches A as well as C. So there are two conditions. A's range will reach B and not C. B's range will reach both A as well as C. Now, A wants to transmit something to B. A senses a medium. It finds the medium to be free. So A will start transmitting to B. So some transmission will be going on between A and B. Now, C wants to transmit something to B. Now, what C will do is, it will go and sense the medium. When it sends the medium, it will find the medium to be busy since the transmission of A reaches B. Because some transmission is going on between A and B, so C will understand that some transmission is going on and it will wait until the transmission is over. Once the transmission is over, C can start transmitting. Now you say that because this waiting time is a problem in this hidden terminal problem, you say that A is a hidden terminal to C and C is a hidden terminal to A. So next we'll see what is meant by exposed terminal problem. Now let us consider there are four nodes. One is R1, the other one is S1, the third one is S2, the other one is R2. So the color which is shown in different colors, this informs the transmission range. So the transmission range of R1 reaches only S1, not S2 and R2. Now the transmission range of S1 you can see reaches both R1 as well as S2. Next, will the transmission range of S2 reaches S1 and R2. The transmission range of R2 reaches only S2 and not S1 and R1. So these colors that are indicated in the figure defines the transmission range. Now let us assume that S1 wants to transmit something to R1. Now what S1 will do is, it will sense the medium. If the medium is free, S1 will start transmitting to R1. Now S2 wants to transmit something to another node R2. Now when S2 senses the medium, it will find the medium to be busy because some transmission is going on between R1 and S1. So since this is a wireless scenario, whatever S1 is transmitting will be received by R1 as well as S2 because the transmission range of S1 reaches R1 as well as S2. Now S2 will assume that some transmission is going on and it will wait until the transmission is over. Now you say that C is, that is S2 is an exposed terminal to S1. So these two problems is the reason why CSMA bar CD does not work in a wireless scenario. Now we'll see how to rectify this problem, hidden and exposed terminal problem. So this hidden and exposed terminal problem, they are rectified using two signals. One is the RTS, request to send. The other one is CTS, clear to send. Now we'll see how the problem is resolved. Again, you consider three nodes A, B and C. The transmission range of A reaches B and not C. Similarly, the transmission range of B reaches A as well as C. Now, A wants to transmit something to B. It will sense a medium. If the medium is free, A will send one RTS signal to B. This RTS is request to send. This signal will have the destination address as B plus the duration, the time duration it is going to take for transmission. Now, when B receives this RTS, B will understand that the transmission is intended for B and so it will send a clear to send a signal. So, since B's range reaches A as well as C, the CTS will be received both by A as well as C. Now, when C receives the CTS, it will understand that the transmission is only for between A and B, and the time duration will be mentioned there. Now, what will happen is the C will wait until the time the transmission is over. Once the transmission is over, now C can transmit to B. This is how the hidden terminal problem is resolved. Similarly, the exposed terminal problem also is resolved using this RTS and CTS signal. Now let me assume that you have one more node here D. Now, when B wants to transmit something to A. So what B will do is, B will send one RTS signal to A. So since the transmission range of B reaches A as well as C, whatever RTS signal B is sending to A will be received by C. So in this RTS signal, the destination node's address will be A's address and the time duration also will be specified. When C receives the CTS signal, C will understand that some transmission is going on between A and B and that is in no way is going to affect the transmission of C. So what C will do is it will start transmitting to another node D which is placed somewhere else. So this is how the exposed terminal problem is um, resolved. So next we'll see what is meant by a near and far terminal problem. So this near and far terminal problem is similar to a person who's standing nearby. If he speaks and the person who's standing far away also speaking, whoever is near to him will be heard louder when compared to the person who's far apart. The same concept here it is applied in the near and far terminal problem. So let us assume that there are two nodes, node A and node B, and this is a CDMA receiver. Now assume that B is very closer to A and A is far apart from the receiver. Now A is transmitting as well as B is transmitting. Now whatever signal B is transmitting will be received properly when compared to A, because the power of this signal B will will interfere with A, and this will be heard as a little bit noise at the receiving end. So whoever is closer to the receiver will receive the signals correctly when compared to the node which is far apart. So this is what you call it as a near and far terminal problem. So these are the two reasons why CSMA bar CD, which is designed for a wired network, does not work for a wireless scenario. One is the hidden terminal problem, the other one is the exposed terminal problem. These two problems are resolved using two signals. One is RTS, the other one is CTS. Thank you.